Now let me state this question. Let G be a continuous real valued function defined on R with the following properties: that G dash of 0 is equal to 0, G double dash of -1 is greater than 0, and G double dash of x is less than 0 for values of x lying between 0 and 2. Now we are given which of the following could be part of the graph G. Part of graph G. So this is the question. Now we are given the following graph. So let me draw these graphs. So this is a -1. This is x, this is y, and at the point 2, this is how the graph looks. So this is A, B is, and then it goes like this, and this is point 2, this is 0, and this is -1. Now C okay, so this point is -1, this point is 2. D this is x, and this is y, this is 2, this is -1, and E this is 2, this is -1. Okay, x and y. Now you cannot outrightly make a guess, right? So have that in mind. Now let me focus on condition 1. G dash of 0 is equal to 0. This means slope at x is equal to 0 is giving us a value 0. When x is equal to 0, the slope is producing a value 0. That means there is either a local maximum or a local minimum or a point of inflection. Okay, now we cannot outrightly decide whether it is a local maximum or local minimum. So that is for condition 1. Now condition 2, G double dash of -1 is greater than 0. So this means at x is equal to -1, G of x is concave upward. So this is a very important point. Okay, so the concave upward means what? The graph has to be U-shaped at x is equal to -1. Now this is the deciding feature. Now go back in the graph and locate for all the graphs where that U is hitting, that lowest point is hitting at x is equal to -1. Now clearly if you see here, this is a potential choice. X is equal to -1, there is that bend, concave upward. So you can actually zero this in. This one outrightly no. You don't see anything of that nature. This one also outrightly no. This one, there is a slight bend, but we cannot make any decision on that. Now this one, absolutely no. This one, absolutely no. So we have, based on the second condition, we have actually gotten rid of these three choices, 1, 2, 3. So there are only 1 and 2 running in the race. Okay, fair enough. So let me go to the next point. Now what is the next point? Next point is g double dash of x is less than 0 for 0 less than x. For 0 less than x less than 2. So let's study that. Okay, so g double dash of x. So between the value of x lying in this interval 0 and 2, our g double dash of x is less than 0. So that means this is concave down. You can probably use the word downward. So this is actually inverted u. So between 0 and 1, or I would say between 0 and 2, the graph should exhibit this structure. So this structure we have to look, that means concave downward. So go up and see which of these are exhibiting. So this point is 0. Between 0 and 2, you see this 2 here? So this actually ends here. The 2 is ending at this particular point. You see this graph? There is a bend. Okay. As I mentioned to you, there are 2 contingents who are running this race. One is A, the next one is D. Now check this D here. Now you see D is coming down, dropping, but the drop is not at 2. The drop is before 2. Okay, so D is off. So the only choice that is in the race and wins the race is A. Okay, so this is a lovely question and you are sure to get questions of this nature. Please like, share and subscribe.